So as I was saying, we have used right angle trigonometry since like Algebra 1 actually is when I teach it. SOHCAHTOA, right? So we've used that forever. It is specific to right triangles. But there will be situations in life, because life is not all right triangles, that you have triangles that are not right triangles. And so what they found is there is a ratio between the trig functions of the angle measure and the side lengths of any triangle, not just a right triangle. Oblique triangles, so triangles that do not have right angles in them. The law of sine says that if you have this triangle ABC here, so this triangle ABC, there is a ratio between the sine of A over the side length of A. Notice the side length of A is the side that is opposite the angle of A. All right? So there is a ratio that is created between the sine of the angle and the length of the side opposite, compared to the other angle, the length of the side opposite of that one, and the third angle and the length of the side opposite. It creates a ratio, fraction that is equivalent. The sine of the angle over the side length will equal the sine of the second angle over that side length. That will also equal the sine of the third angle over that side length. That is the law of sines. They will equal each other. All right? So how does this help us? Look at example 1. Look at example 1. All right, they have given us this triangle here, triangle ABC. They want us to solve it. What does solve mean? Give me the angle measures and the side lengths of the ones I don't have. So when I solve a triangle, I write all of them out. So I write the measure of angle A. They gave me that. The measure of angle B, they gave me that. The measure of angle C, I need to solve for. If I have 2 out of 3 triangles, how do I solve for the third? Or 2 out of 3 angles in a triangle, how do I solve for the third? Yeah, 180 minus 35 minus 103. Angle C is going to be 42 degrees. Just subtract from 180. That's what they add up to. And then if I'm solving the triangle, I also need the measure of the sides. The measure of side A, the measure, and you can just write A. We don't have to write measure. That's going to get confusing. All right, so I need the length of side A, the length of side B, and the length of side C. They only gave me one of my lengths. Which one did they give me? B. All right, remember it's opposite the angle, so they gave me B. All right, so you are going to start with the one that you have both of. By that I mean I have both the angle measure and the side length for B. That's the one I'm going to set up first. So I'm going to say, well, the sine of B, that's 103, over the length of B will equal the sine of A, which is 35 degrees, over the length of A, which I do not know. How do I solve? How do I solve ratios? Cross multiplication, right? So A times this, so A times the sine of 103 should equal 20 times the sine of 35. I'm solving for A. How do I solve for A in this algebra problem? Divide by? There we go. And you can do all of this in your calculator to get it exact. It wants us to round to the nearest tenth. So in your calculator, you're going to say 20 times the sine of 35. If it opens parentheses, make sure you close it there. Divided by the sine of 103. Make sure you are in degrees, not radians, because that's what we're in. You should be able to plug it all in. A to the nearest tenth should be approximately 11.8. Now, the sine of A over A should also equal the sine of C over C. But always go back to your original, the one you have not rounded yet, if you can. All right? Because the more you round, the further away from actual you get. Meaning, I now need to solve for C. I'm not going to use A because I've already calculated him and rounded him. I'm going to go all the way back to this one. So now I'm going to set up C the same way. The sine of B over the length of B should equal the sine of C, which is 42, over the length of C. It's going to work out the same. C is going to equal 20 times the sine of C divided by the sine of B. The setup is going to be identical. And then you'll plug that in and get C as well. So we now know A, and we now know C. When we have all 6 of these, we have solved the triangle, which is what it told me to do. An Earth orbiting satellite is passing between the Oak Ridge Laboratory in Tennessee and the Langley Research Center in Virginia, which are 446 miles apart. If the angle of elevation to the satellite from the Oak Ridge and Langley facilities are 58 and 72 degrees respectively, how far is the satellite from each station? And they were nice enough to draw a picture. Keep in mind that the angle of elevation from Oak Ridge corresponds to the distance from Langley, because it's opposite, okay? So just keep that in mind when you're calculating these. So you do need to draw a picture if they don't draw one for you. So the distance apart from these two guys, that's this right here, the 446 miles. Satellite, he's obviously up here in the air. All right, and then the angle of elevation, that's from this land up to the satellite. That's 58 degrees. Elevation here, 72 degrees. So if I want to find the distance from Oak Ridge to the satellite, I'm actually using the Langley elevation here, angle elevation. Do you see that? So when you draw these pictures, you're going to have to draw them out, label them so that you know what you're looking for when you find it. But this is basic law of sines. That's all we're doing here is law of sines. So I could have drawn this anyway. I could have drawn this Oak Ridge over here and Langley over here and just labeled this 58 degrees and labeled that one 72 degrees. And it doesn't matter as long as you understand what angle of elevation means and distance apart and things like that. Okay? Elevation is identical to the problem we just did. We would say, well, if I'm solving for this, I'm going to say the sine of C over my side length. The problem is they didn't give me C. However, I have 2 out of 3 angles in a triangle. How do I find C? Yeah, so I'm going to say 180 minus these 2. Yep, and I'm going to get this guy right here, which is what, 50? So this is 50. So then if I want to solve for A, I'm going to say, well, the sine of 50 over my length across from that, 446, equals the sine of 58 over my A that I'm solving for. And then use law of sines, cross multiply, right? You would say A is going to equal sine of 58 times that 446 divided by the sine of 50. When they did that one, what did they get? 446, we get what? 493.74. So the distance from Langley to the satellite is 493.74 miles. And to solve the other guy, we do the same thing with 72 degrees, right? So we just say, okay, well, to solve this guy, that's going to be 446 times the sine of 72 divided by the sine of 50. That's going to be my B. And this guy, when they solved it out, was approximately 553.72 miles. All right, so same thing happens here. Law of sines, law of sines. So try guided practice 2 there. They give you a shipping example.
The geometry coefficient of the parabola.
All right, so when you have an angle and a side opposite, and you have both of those, you'll use law of sines. It's easier, okay? But there are going to be situations when you don't have the side opposite of one of the angles. So you have angles and you have sides, but none of them pair up to the side opposite. And so then all of a sudden we have an issue and we cannot use law of sines. So we're going to use law of cosines, which is this guy right here. He is not as user-friendly as the law of sines, okay? I promise he's not. Now, you do not have to memorize 3 of them. They all work the same. What you'll notice is that the guy that's on the outside is always going to be the one over here that you're taking the cosine of. All right? That's what you need to know. You don't have to be, okay, I need to know the a squared one and the b squared one. You don't have to know that, okay? You just have to know that whatever the length is on the outside, that's the angle you have to use at the end of this formula. So the formula is I have a side squared. That's going to equal my other 2 sides squared and added together, and then subtract 2 times those two sides times the cosine of my side that's on the outside. So the way they say it is a squared equals b squared plus c squared minus 2bc cosine of a. You just have to know that one. You just need to know that the one on the outsides match each other. The side length that's all by itself matches the one you're taking the cosine of, okay? Now, what this does is this opens up those not necessarily having to be opposite. I mean, not having to have both of those, okay? So that means I have the angle of the cosine, I have the side length of B and C and the angle A, but I don't have any opposites. So I can solve for my other side length using this guy, okay? When a hockey player attempts a shot, he is 20 feet from the left post of the goal and 24 from the right post. So they've given me side lengths, right? 24, 20, and 20. 20 and 24. The regulation goal is 6 feet wide. They've given me the third side length. So I know all 3 side lengths, 20, 24, and 6. Okay? Everybody see that? It says, what is the player's shot angle to the nearest degree? So we have this triangle, and I'm going to draw it out here. Right, we have this triangle right here. Triangle A, B, and C. We want angle A here, right? We want this angle. That's what we don't know. We know side lengths, 26 feet and 24 feet. All right, so this is where we're going to use the law of cosines. Law of sines does not help us because we don't have an angle and a side opposite, okay? What am I trying to solve for? I'm trying to solve for A. So that is the one I'm going to need to use cosine of, all right? If you're solving for an angle using law of cosines, then the one you're solving for is the one you need to put there, which means this side right here is the side that's going to be on the outside, okay? Because they need to be opposite of each other. So how do I set this up? I'm going to say a squared, that's going to be my 6, equals my other two sides, 20 squared plus 24 squared minus, and then I'm going to subtract here, 2 times 20 times 24, those two I just used, and then I have the cosine of the guy I don't know, okay? And now you're just solving. You're just solving, okay? So we're literally just going to solve this guy. 6 squared, well, that's easy. 20 squared, that's also easy. 24 squared, 576. Minus, we have this guy, 2 times 20 times 24. What did they say that is? 960 cosine of A. We good? Now I'm going to add, right? Add these two guys, right? 36 equals 976 minus 960 cosine of A. Subtract this guy over. Right? We're just doing basic algebra. 36 minus 976. All right. What do I do here? I divide, right? So divide both sides by negative 960. So we have the cosine of A equals, and negative divided negative is a positive, 940 divided by 960. What am I going to use? What function feature am I going to use if I need to find the angle? Yes, on your calculator you're using arc cosine or inverse cosine, correct? So that means if I know the cosine equals that, to find the angle, to find the actual angle, I'm going to say in my calculator, this guy of 940 divided by 960. Make sure you are in angles, not radians. When you do that, you should get approximately 11.7 degrees. So you're literally just adding, subtracting, dividing, and then doing arc cosine. Arc cosine. Let me say this. At this point, if they wanted all of the angles, let's say they wanted me to find angle B and angle C. Guess what I'm not doing? I'm not using law of cosines. Because it's more difficult. I now know an angle. I know this is 11.7 degrees. I'm going to use law of sines here. I'm going to say sine of 11.7 over 6 equals sine of b over 24. And yeah, I'm still going to have to use arc sine to find it, but it's just one ratio here instead of doing this whole squared, minus squared, all of that stuff, okay? So if you were solving a triangle, you can start with law of cosines, right? Then you can use law of sines. And then once I solve for b, guess what I'm not doing then? I'm not using law of sines. I'm subtracting from 180 because at that point I'll know 2 out of 3 angles, okay? So it's not like you have to use law of cosines 3 times to solve for the angles. You really have to use it once because then you have an opposite. You can use law of sines. Then you have 2, subtract from 180, and you're done, okay? Make sense?